With many of our clients, Douglas Partners are well established as the go-to for engineering and environmental solutions, site investigations, and groundwater, not to mention Level 1 inspection and testing. However, some of our clients may not be as aware that DP can tackle most Level 2 testing requirements as well. As we move into 2021, it is important that clients begin to see Douglas Partners as a one-stop shop for all aspects of geotesting. Educating clients about DP's capabilities is an ongoing initiative, and this education should begin well before setting foot on site. From receiving the initial RFQ and carried right through from the tendering process to the close of the project, DP's abilities and skill set must be demonstrated at every level. As we move through this presentation, we will discuss strategies to maximize profitability and to upscope testing wherever possible. We will begin with Level 1 testing and discuss the utilization of assigned values, day rates as compared to hourly charges, quality checks for bulk fill, including PSDs and Atterbergs, treatment of oversize, and retests. We should also consider potential acid sulfate material, as this can be a factor in the bulk filling process. We will discuss initial pH testing of disturbed fill, chromium suites, verification testing, and lime spread ratios. In tandem with bulk earthworks, many sites are designed with a biofiltration basin which works to catch and hold site runoff. The water held by the basin offers testing opportunities, but the basin itself, including the floor, bund walls, and filter media, often will require additional and specialized testing to prove conformance. This brings us to Level 2 testing. It is usually the case that roads will be shaped through the bulk earthworks process. Further refinement of these roads occurs as the job progresses, and many testing opportunities will manifest, including subgrade CBRs and limits, material qualities, including CBRs, PSDs, and Atterbergs, and base densities in quarried gravel. It is important to note that assigned values can often be maintained for these gravels, which will both speed up density results and allow confidence in field density readings. In line with the roads, Level 2 works can also include the testing of backfill for service trenching, such as stormwater, sewer, water reticulation, and sometimes electrical conduits. Consideration must be made for the local authority of a project, as this will often affect testing frequencies and may call for testing of bedding gravels or trench foundations. After subbase is placed, curbing will often be constructed prior to the placement of the base course. Curbing is only one example of concrete testing, and there are other opportunities on site, including driveways, structures, footpaths, pits, slabs, and footings. Footings themselves usually require a DCP to ensure KPA conformance. As you can see, there's lots more than lots to geotech, and leveling up our testing game will maximize profitability, ensure a steady workload, and, perhaps most importantly, keep other testing companies off of a site on which DP is already established. But before we get ahead of ourselves, we first have to win the work. So when you're checking your email and an RFQ comes in, if you're lucky, the estimator will have provided you everything you require to accurately price the work. Study the provided BOQ, the project drawings, and the construction notes. After familiarizing myself with the particulars of the project, I usually respond that I intend to quote and ask any questions I might have at that time. This will both let the estimator know that you're keen for the work and also allow any confusions to be clarified early on. I often find this exchange an easy way to initiate dialogue with the client, and this dialogue should be maintained throughout the entire tendering process. Once I've gotten my head around the scope of the project, I will begin drafting my proposal. I try to simplify the work involved into an easily understood format with tables that do not require interpretation. I usually separate bulk earthworks into one table with a subtotal, and include all Level 2 into a separate table with its own subtotal. After consultations with several estimators on how they prefer tenders to be presented, I have found that most will prefer a lump sum approach. This is not always easy to achieve, as the testing requirements can sometimes snowball beyond the initial scope. These extra overs can usually be treated as a variation to the quote and be addressed smoothly. When preparing an estimated lump sum tender, certain key points should be considered. I will factor in local authority requirements when counting testing frequencies for Level 2, and I also separate the various levels of work, such as subgrade, base courses, trenches, etc. The goal is to clearly lay out the requirements of the project and arrive at a working lump sum that allows for some wiggle room to accommodate any changes as the works progress. Don't get bogged down in the details. The client doesn't have time to sift through the wordy proposal that attempts to cover every possibility, and neither do we. A ballpark lump sum is usually sufficient and allows the estimator an apples-to-apples comparison with the competition's tender. There is always room to include for variation as the job progresses. Factor in travel times when you are quoting for establishment. Aim for a door-to-door charge, although this is sometimes not as competitive and can lead to a lost project. If you have other projects in the area, this could be factored in to lower or eliminate the establishment charge. Be sure to follow up. This is perhaps the most important step. Allow yourself some wiggle room with your quote in case you need to narrow your rates a bit. Good news, your tender was successful and you've been awarded the project. Time to head for site for a stripping inspection and to discuss logistics with the foreman or engineers. I usually charge a 2-hour call-out at minimum for this. Tack a bit extra on if they require a letter of confirmation. While you're out there, have a look at the in-situ material. Is it uniform throughout the project? There may be an option to establish an assigned value for the material, which can speed up the lab work and increase the profit margins for the project. Be sure to regularly update the AV so as to identify any variation to material as the cutting progresses. Ensure the technician on site keeps their time charges in line with the placement of fill. If it's only trickling in, a half-day charge may be more appropriate, and this can free up the technician to follow through with Level 2 testing on other projects or to assist in the lab. Some project-specific construction notes may require PSDs or Atterbergs on bulk fill material. This can be especially true for rocky sites where oversize can become an issue. If the construction notes do not call for material quality checks in the bulk filling, you can sometimes successfully suggest that they be undertaken. If there is a great deal of oversize on site, V-molds will generally be required. We include for this with a footnote in our proposal. If failures are found in the fill, I require my technicians to make comment within their Level 1 day sheets to reflect the cause of the failure. Material not conditioned properly despite discussions with foreman, etc. The technician will then retest the failed areas, and we will be able to charge for both the failure and for the retest. Certain sites may contain potential acid sulfate soils. If this is the case, you may be required to conduct initial field pH testing. If the soil comes back as acidic, then chromium sweets are in order. We outsource this testing with 20% loading. From there, a liming rate can be established that will bring the soil pH into check. There is a potential to monitor the lime spread rate if the client requires. This will ensure the material receives the appropriate liming ratio. Once lime has been mixed and material placed, pH verification testing is usually required to confirm the material pH has been brought into spec. If the verification testing fails, the process should be repeated until material falls into line. Are there bioretention basins on site? These offer opportunities for testing as well. The basin foundations and bund walls generally require permeability testing. They may also require material quality tests including Atterbergs, PSDs, and Emersons. If a filter media is placed in the basin floor, then there is opportunity for single or double ring infiltrometer testing and an accompanying factual report. The water held in the basin may also require testing. pH testing will be required to release water from a dam. Electrical conductivity, dissolved oxygen, total suspended solids, and turbidity are other tests that are often required. While technicians are supervising Level 1, they may observe Level 2 works occurring on adjacent stages of the project. I encourage my technicians and coach them with strategies to win adjacent works. One way of getting a foot in the door is to mention that, in fact, DP already has a foot in the door. Any need for Level 2 testing is that much easier for the client if we are already on an adjacent site or project for Level 1 inspection. If the client only has to make one phone call and can avoid an extra establishment, then it is often a no-brainer to continue working with DP through the Level 2 stages of work. Techs may also point out errors they notice in filling operations on adjacent sites. I encourage my techs to get nosy and get involved. This is the best way to drum up new work and firm up new relationships with the client. If not already on site for Level 1, I find it cost-effective to aim for a minimum number of Level 2 tests, usually 10 or more, per visit. This ensures we aren't losing money in travel time, where one trip can often cover the work of 2 or 3 if communication on site is maintained. Trenching is often excavated for conduits and pipes in tandem with bulk earthworks filling. It is a good strategy for a technician to stay on top of the Level 2 backfilling as it progresses so as to avoid playing catch-up. This Level 2 testing can often be attended to while monitoring the placement of bulk fill. In this way, the technician can continue to charge the hourly or day rate Level 1 charge while also picking up available trench testing as the job progresses. As the technician should be familiar with the in-situ material placement requirements, they can often offer input regarding compaction or moisture as the material is placed. This is another incentive for the client to continue working with DP beyond Level 1 bulk filling. Along with trenching works, it is usually the case that roads will be shaped through the bulk earthworks process. Once the road has been bulked out, subgrade CBRs can be sampled and tested. This will allow for paving designs, and CBR limits are usually required. I charge a minimum of 2 hours for CBR limits, and this will cover my time in the office drafting the report and plotting the limits on project drawings. Time on site is usually charged by the technician for visual inspection of the subgrade surface to ensure that limits reflect any material changes. After a paving design has been established, the road will be boxed out. If the CBRs come back low or with a high swell, some sections of the subgrade may be boxed further down and reinstated with a subgrade replacement. Depending on the local authority, subgrade replacement usually requires a material quality on quarried material which achieves a minimum of CBR 15. PSDs and Atterbergs may also be required. Once the subgrade has achieved a final trim, it will usually require a council proof roll. I am sometimes requested by the client to be present for this, and will charge a minimum of 2 hours for the inspection. Generally, a layer of subbase is then placed, followed by a layer of base gravel. Each of these layers will require material qualities and field densities. Assigned values can often be maintained for these gravels, which will both speed up density results and allow confidence in field density readings. Once the subbase has been placed, curbing will be constructed and then tied in with the base layer. This is just one example of concrete testing opportunities. Others include manhole structures and pits, footpaths, and driveways. If a project is for a building foundation, there may be footings as well. Footings will not only require concrete testing, but also DCP testing in the foundation to ensure the required KPA is achieved. Concrete cylinders are required to cure overnight and must be picked up the next day. If the technician is not already attending site for other testing, there is an opportunity to charge an additional establishment for the retrieval of cured cylinders. As you can see, there are many opportunities to upscale testing from the stripping inspection right through to road sealing. From the moment the RFQ comes through, it is important to fully grasp the scope of the project and identify potential revenue streams. This can be communicated through the proposal and with follow-up conversations with the client. Once on site, technicians should be coached to keep pushing for further ground, finding opportunities and keeping in the client's ear. There may be other projects where the client is not happy with the service they are receiving. Intel like this is invaluable and can be used not only to keep the competition off of our turf, but to gain ground on theirs.